Going to question 21, starting this question, we have something really interesting right here. We have the square root of something squared. So let's write that like this. The square root of something squared. Well, the exponent and the radical there cancel each other. So that's just a. Square root of a squared would just be a. Similarly, square root of this thing squared is just this thing, x minus 2. And that equals the radical on the other side. Now, we're in a regular radical equation situation where we can just square both sides and actually get rid of the radical on the right-hand side. On the left-hand side, we have x minus 2 squared, which looks like this. Squaring a number means you're multiplying it by itself. So now we can FOIL. We can do first times first, which is x squared. We can do outer times outer, which is negative 2x. Now we can say inner times inner. That's negative 2x again. And last times last, negative 2 times negative 2. And that'll be positive 4. And that still equals 3x plus 34. Make it a little neater. So combine some like terms here. Minus 2x and minus 2x is minus 4x. Now we have a quadratic, so we can get everything on one side equal to 0. So minus 3x minus 34, minus 3x minus 34. And we have x squared minus 7x minus 30 equals 0. And when you have a BC quadratic, which is what we have here, because it's in the format of ax squared plus bx plus c, and we have numbers in the b and the c spot, but nothing except the invisible number 1 in the x spot. So that's a BC quadratic. And in that situation, you need two numbers that add to b and multiply to c. So two numbers that add to minus 7 and multiply to negative 30. And those two numbers are negative 10 and positive 3. So x minus 10, x plus 3. And now that we have it all factored in a nice factored manner here, we can use the zero product rule, which says that if these two things equal 0, if they multiply to 0, that could only happen if one of them were 0. So we'd set each individual one equal to 0. So you can add 10 to both sides here and get 10, take away 3 from both sides here and get negative 3. And our two answers are 10 and negative 3. Now be careful, because with radical equations, you have to plug your answers back in and make sure they make sense. So let's do that. If x equals 10, we'd have square root of 10 minus 2 squared, so 8 squared, which is 64, equals square root of 3 times 10, 30 plus 34, which is 64. So that's pretty good. And if x is negative 3, we'd have square root of negative 3 minus 2, which is negative 5 squared, equals square root of 3 times negative 3, negative 9 plus 34. And so here we have square root of 25 equals square root of 25. So both of them work pretty well when we plug them back in. So then which of them is actually the smallest one? It's the negative one. So our answer is negative 3.